Welcome everybody again. Here I wanted to go back to our lectures 19 and 18 and look at an issue or a problem where we have some information about near future, but not so much information about future that is further away. Now that may put a smile on your face or a frown, given the current circumstances. But in principle, um, in general, we can say more about more recent, more near future than about the future that is further away. And this example deals with that. Here we have a company that is making a new investment. They can predict something about the effects of this new investment on their cash flows in the next few years. But then after that, things will probably come back to normal, or they're just not sure what they're going to do. 4, 5, 6 years from now. So they will project more detailed cash flows for the next 3 or 4 years, and then for the period after that, they're just going to assume some constant growth rate after that and calculate their cash flows. So in this case, we have a company has just invented a potato chip that looks and tastes like a French fry. Given the phenomenal market response to this project, Small Fry is reinvesting all of its earnings to expand its operations. Now, we start with earnings of $2 per share. That's a fact. We know that right now. Those are the current earnings. That's from the past year. And they're expected to grow at a rate of 20% per year until the end of year 4 because of the new project. At that point, other companies are likely to bring out competing products, and then your growth rate will probably going to slow down, and we see that here. Analysts project that at the end of year 4, Small Fry will cut its investment and begin paying 60% of its earnings as dividends. Its growth will also slow to a long run rate of 4%. That's what I mentioned when we know something about the near future, but not so much about the far future. We're going to assume a constant growth rate after year 4. So we don't know too much about it. So how do we deal with this? So what we're going to do is we're going to use their projected earnings, and I'm going to jump into the table here. Now this table may look confusing, and I'm going to bring it a bit closer to you. Let's see how that looks. Even a bit, even more. There we go. That's perfect. Okay, so what we know here is these $2 earnings per share. That's in year 0. That happened already last year. And then it said their earnings are going to grow 20% per year because they're putting all of their net income into this new project. So earnings grow at the end of year 1, year 2, year 3, end of year 4. They grow by 20%. And then they say at the end of year 4, or after year 4, earnings are going to grow by 4% per year. 4%, 4%. So based on this number that we know, we can actually derive the rest of these numbers. So this is 20% more than $2. This is 20% more than $2.40, and so on. So based on these assumed percentages, we have derived these numbers here. Now, when it comes to dividends, it says dividends are going to be, let's see, so we're going to have 0 dividends in year 1, 2, 3, and 4. Sorry, year 1, 2, and 3. And they say Small Fry will cut its investments and begin paying 60% of its earnings as dividends at the end of year 4. At the end of year 4. So at the end of year 4, they start paying 60% of their earnings as dividends. So that's also given to us. 0% until the end of year 3. So based on that, we have no dividends end of year 1, 2, and 3. But based on these assumptions, at the end of year 4, we have 60% of this, of earnings per share, dividends, and then 60% of this dividends, 60% of this dividends. So that's how these numbers are produced, mainly based on assumptions. And the main number that we actually had was this one here, so $2 per share earnings per share. Okay, so we know that their dividends are going to look like this. And so if we wanted to use the constant dividend growth model, we can calculate the present value. Let's go back. The present value of all these dividends. Now, it may be useful to put it on the board. Let me see. I think it's going to work. Zero, 1, 2, 3, 4, 5, 6, 7. Now, if we go back to the table, year 0, nothing. Year 1, 2, 3, nothing. So that's 0, 0, 0. And then at the end of year 4, we have 249, then 259, then 269. 2.49, 2.59, 2.69. And then we have other dividends. So year 4, 5, 6, and then year 7, 8, and so on. We have other dividends that grow at 4% per year. So 2.49 to 2.59 is 4% per year. And then we have from 2.59 to 2.69, 4% per year, and so on. So we have actually 4% per year growth here. So we could use present value of perpetuity to calculate the present value of this. But there's a catch, and we'll show what the catch is. So if we calculate present value, that's going to be dividend. We're going to use the first one, 2.49, and then RE minus G, opportunity cost of equity, minus G, growth rate. And so that's going to be 2.49 here, 2.49 here, and then RE, it's actually said in the description of the model, it's 8% per year, so 0.08, and G is 4% per year, 0.04. And so what we're going to get is 62.25. Now, what is that? Where does that apply? 62.25. We calculated the present value of these cash flows that go forever like this. But remember, when we have an annuity, 0, 1, 2, 3, and so on, we have cash flow 1 here, cash flow 2, C1, C2, C3, and so on. When we calculate the present value, it applies here. Now see, our cash flow start at year 4, so the present value that we're going to get for all of these cash flows is going to apply to the year 1 period before where the cash flows start, which is year 3. So this 62.25 actually applies to this point here, to year 3. So it's as if you got a lump sum of 62.25 at this point, instead of this perpetuity. So this this number here is actually not the actual present value of the stream. It's as if you received it at the end of year 3. So for us to figure out what this would be if you received it at the time 0, we still have to discount it by 1, 2, 3 periods. So that's why we have to take this 62.25 and discount it like this. The present value of this at time 0. So this is present value at time 3 here. This is present value at time 0 is 62.25 divided by 1 plus our RE is 0.08 and then to the power of 3. And that's going to give us the actual present value of that perpetuity that applies at time 0. And that's going to be 49.42. Okay, so let's see how that looks on the video.